welcome back to the third Unity video. Today, we're actually going to be starting to make a game. So you'll be able to use everything that you've learned in the first two videos, bring it all together, put it in Unity, and make an actual game. So before you even start making your game, you need to come up with an idea of the game that you want to create. I already have an idea of a pretty simple game that I'm going to be leading you through, and it's a asteroids-like game. In this game, I have the idea that the player is going to be alone in some sort of environment, probably space, and there will be asteroids gravitating towards them, and they must use their ship to destroy the asteroids before it touches them, and therefore ending the game. I have a couple ideas of how I want to go about this, and I think I want it to be a 2D top-down kind of twin sticky shooter where the player is going to be using WASD to move and the arrow keys to shoot in the cardinal directions. And I think that's going to be the game I'm going to make. It's once we start making it and finish an actual game, we can put polish on it, like adding a score multiplier, creating menus, and such like that. So normally when you're creating a game, and especially if you're creating a game with a group of people, you need a way to establish your idea as kind of the core idea that everyone's going to have. Because if you tell your idea to everyone, they're all going to have different visions of what it's going to look like in their heads, which is why things like documentation is incredibly important. So normally I would suggest doing a visual design document. And I'm sure many of you know what a visual design document is, but for those of you who don't, it's a document basically describing your game visually. So it's supposed to take all of the important aspects of the game, like how to play, the obstacles, the goals, and put them on one or two sheets of paper and visually explain it. Then there should be as little words as possible there, and it should be very intuitive and should make really anyone who sees your game understand what the feel of the game is, understand how the game works, so that you could basically give this document to a programmer and come back when the programmer is done, and they would have the entire game programmed the way that you would like. Now, that's a bit of a stretch, especially for small teams, and well, even with small teams, they're going to be working closely together, but you get the gist of what a visual design document is supposed to be. An art Bible is kind of the same thing, but with art, it has the stylistic choices, the color scheme, all of the art, all of the art in it that would give the feel of the game world, its own personal touch. Like if you analyze the different art styles of, let's say, the BioShock series to the Mario series, they're completely different, and each art style wouldn't fit in the other one because of the feel of the game. That's where an art Bible really comes in handy. So after you have really documented everything, really typed out what you want your game to look like, and even if you're just working on a one-person project, I would suggest making at least notes for yourself, because you are going to come back to it at some point and say, hey, I have no idea why I included this one thing, I have no idea why I made this design choice. And if you didn't have a design document or some kind of documentation to tell yourself why you did it, then you might just end up, deleting that work, starting over, and then at some point later in the future realizing, oh hey, I kind of did need that. So yeah, that's the importance of documentation. I would show you the documentation I made for this, although I haven't made it right now since I'm just starting it. But since it's a small project, I think we can probably get away with not a lot of documentation. This project should only take a couple hours to do at most, maybe even just one if we do it correctly. So the first part of making a game is making a playable prototype. Now, at least the way I make games, everyone has their own separate style, but I like completely making the game by itself, making a playable prototype, making all of the systems work, and then adding polish, adding art, adding menus, and stuff like that. Some people, some designers choose to make the art up as they go. Some people like to start with the menus, some people just like to hop into the main gameplay. It's all up to you. That is up to how you make games, how you design games, and all of that is personalized to what you do. So for me personally, like I said, I make the game in a playable prototype state, then I start adding on to it. I start making sounds, I start making art, I start making menus after I have a playable game. So, now that I've talked a lot, I think it's time to start. So let's go ahead and open up Unity. And we are going to make a new project. We're going to call this, let's call this Asteroids. Yeah, that's right. If it's not right, it's creative spelling. So we're going to put this on 2D. Make sure you save it wherever you would like. And after you've done that, go ahead and create the project. Unity is going to load up, and then we can start to get in to making our game. There we go. Let's turn off that services tab. We don't need you right now. And let us start with our game space. So right off the bat, I know this is going to be in space, so it's going to be a majority black background. So let's just start with that. I'm going to make a, I'm making a 2D object, sprite, and I'm going to call this background. I'm going to use some of the default sprites that Unity gives you. These are all of them over here. They're really good for just placeholder art. I use them a lot. So I'm going to use background for background. Let's make this 150 by 150 just to make sure the scale is correct. And we'll make that dark black. That way we don't have that tingy blue in the background. Before we start, let's go ahead and save this. I'm going to save this as game, and I'm going to put this in its own folder called scenes. There we go. Okay, so now let's start making our player. Our player is the most important object because it's the one that the player obviously is going to be using. So we are going to use a simple square for this. We're going to use the input field background, UI sprite, man, they're all the same. We'll just use this one. It's going to be there. We're going to make this let's say 5 by 5. Yeah, that seems pretty good. Let's start the game on full screen to see how that's going to look. And yeah, that looks like a pretty big workspace for the player. So we're going to get out of there, and we're going to start programming. So we're going to put a script on this. I'm just going to go ahead and create it in here. And we're going to call this player movement. Also, I should name this new sprite player. So I'm going to take player movement, drag it onto the player. Now it's there. And let's open it up in Visual Studio. Okay, so now that Visual Studio is open, we can start with the absolute basics, and that is getting the player to move. So right off the bat, I know this is going to be an update because we want to check to see if the player is moving every single frame. So we're going to do if input.getKey, we're going to use just normal getKey, and we're going to say left. Left is, or actually, let's do A. Yeah. A is the term for the A key. We're going to put some brackets down in there. And then we're going to say this dot GameObject dot transform dot translate translate, there we go. And then we're going to put this at 0.01f00. There we go. So what this is doing is it's saying once the player pushes down the A button, then it's going to be translating that to the negative to the left. So we're going to copy and paste this to do it for all of the directions. And one more here. Okay, so now we're going to do D, and that's going to be in the positive X direction. Now we're going to do W. We can just go ahead and take this, oops, and put that in Y, although without the negative. And then we're going to do the same thing for S. There we go. So let's go ahead and build that with Shift Control B. It is built. Come on into here. It's on our player, and let's go ahead and see if it works. Ooh, that's a little slow, isn't it? Why don't we go ahead and turn up that speed a bit? I think 0.1 instead of 0.01 is probably what I meant in the first place. There we go. Get that to load, and yes, that is definitely a lot better. So we do have the problem now of the player can go off screen. We don't really want that to happen, so let's put some limits on what the player can do. Let's say if the A key is pressed down and this dot game object dot transform dot position dot x is not equal, or actually no, we're gonna do so basically what I've set is it's saying if the A button is pressed and the player's X position is we want it to be greater or equal to 4.5, then it's going to do that. And the reason it's 4.5 is if we look on here, up in Inspector, we have the player's X position, and we want them to stop probably right about there. So actually, I want it to be 8.5. And then down here, we're going to want that to be 4.5. So let's go ahead and change that. This is going to be, as long as it is greater than 8.5, we can copy and paste that, repeat it. Oops, that should be a negative 8.5 now that I think about it. We're going to repeat it for this. That's going to be as long as it is less than normal 8.5. And then we're going to copy and paste this. Make sure to change this to the Y direction now. And that's going to be 4.5. Now let's check to make sure that's correct. So we want it to be less than positive 4.5 in order to move up. And then we're going to copy and paste this into this one. And it's going to be as long as it is greater than negative 4.5. Let's build that. Go over to our Unity scene, play it, and see how that works out. Well, I can't move further than that. Can't move further than that. Can't go further down than that. And can't go to the right further than that. Seems pretty good. I don't like that the player is touching the screen there. So I think I'm going to increase that to 8.25. Just to make sure that they get a little bit of extra padding. And let's test that out to make sure that feels right. Yep, that feels pretty good. There we go. Although, it is a little weird that I can go all the way up there, but not. But I think we can just keep it like that. I don't think the player is going to be pushing up against a lot of walls in this game. So now that we have that done, let's take our player and make it a prefab. So down here, well, we also need to make a folder for our scripts. And that's going to be thrown in there. And then let's create another folder for our prefabs. And our player is going to be thrown in there. So now that the player can move around, let's give the player a weapon to defend themselves with. Now, with this game, the player is probably going to be a spaceship, so I want them to be able to fire a weapon from their spaceship in, let's say, the 4 directions. So what I'm going to do right now is, oops, just go ahead and reload that. If that error ever comes up, just hit reload all. Asteroids. Sometimes this happens. It's because I moved the script. If you move the script around and it tries to open it, just restart it. Also, line endings come up a lot with Visual Studio. I think it also comes up with MonoDevelop. Just change line endings. It's fine. It's not going to affect your game. So coming back to normal game area, we want the player to have something to fight with. So I'm going to go ahead and create a copy of the player. I'm going to scale this down to 2 and 2, and I'm going to make this red, like a nice bright red. And I'm going to call this bullet. I'm going to take away the player movement script, and I'm going to make this its own prefab. There we go. So now the bullet is its own prefab. It has pretty much nothing on it. So we're going to go back to our player movement, and we're going to say, okay, let's do if input.get key. We're going to do down. Or actually, no, we're still going to do get key, because I want to put this on a timer, so they can't just spam bullets in a straight line. So let's do get key. I'm going to say left. Oh, that's not left. If input.getKey left, I'm going to put that there, and we're going to use instantiate. So we're going to do instantiate, and instantiate is really cool. If you hover over it, you can see what it takes. Right now, it looks like I need a original, which is a game object, vector 3 position, and quaternion rotation. So I made the bullet a perfect square, so we don't have to deal with rotation. Rotation is a little bit tricky, especially when you're trying to instantiate something. So I would suggest going on that alone if you really want to figure it out. Definitely use the Unity documentation. It's really helpful. But for the purpose of this game, we're just going to be doing quaternion.identity, which is the rotation of the prefab. So we're going to do up here at the top, we need to do public game object, and we're going to call this bullet. Down here, we're going to say, okay, so we're going to make the bullet. It's going to go to new vector 3. So where do we want to put this? Well, first off, let's just end this really quick so it won't yell at me. And we're going to do quaternion.identity. So where do we want this bullet to come from? We want it to come from the left of the player. Now we can't spawn it directly on the player because then the bullet would be inside it and that wouldn't make any sense. So what I want to do is I want to spawn the bullet 1 unit away. I believe that will look. Let's see. Let's change this to a 1. So if we spawn the bullet there, nah, I don't like that. Let's play around in here. Let's see how far away we can spawn the bullet. Let's see. What about 0.5? Yeah, that looks pretty good. It's close enough to the player to make it seem obvious. So we're going to delete that bullet. Now we know it's 0.5. So what we're going to do is we're going to create a new float. We're going to do float. We're going to do player x pos for player x position. And that is going to equal this dot game object dot transform dot position dot x. So what I've done there is I've set player x position to the player's x position, and what I'm going to do is I'm going to say, okay, the new vector. Well, actually, I'm going to want this to be, instead of player, it's going to be bullet x position. And that way I can just add the numbers right in here, and I want it to be, to the left, it's going to be negative 0.5f. So in here, since it's x, we're going to do bullet x position 0, 0, because we need 3 vectors, and there we go. Let's go ahead and save that and test it out just once to make sure it works. So I can still move around normally, and I press left. Oh, and we see down here the variable bullet player mode has not been assigned. So I need to go to player, and we need a bullet. So down in the prefab, it's going to drag that bullet in there, and now it should work. Boop, there's the bullet. Now you may have noticed the bullet doesn't move. We need to code that in later, and as you can still see, we're having a little bit of problems. For one, I forgot to take the player's X position of it all, or player's Y position, so it's constantly moving the bullets on one certain path. So let's go out through here, and we're going to say that the bullet X position is also going to be equal to, or the bullet's Y position is going to be equal to this dot game object dot transform dot position dot Y. So now that we have the bullet's X position and the bullet's Y position, that should work once we build it, run it, and test it out. There we go. Maybe I can make something like a smiley face. I'm not an artist. Okay, so the bullets are spawning a little bit too fast, but we can fix that. First things first, I just want to get all of the direct, or actually I should probably fix it before I copy and paste this all. So what we're going to do is we're going to say, we're going to create a variable, and that's going to be a boolean called canFire, and we're going to set that immediately to true. And we're going to say, okay, as long as getKeyLeft and canFire. Now, if you leave it just like this, if it's a boolean, if it's true, it will pass. If it's false, it won't pass. So you can just leave canFire. So what this is saying, as long as left is pressed down and canFire is equal to true, we will be fine. So we're going to instantiate that. We're going to put canFire equal to false here. And what we're going to do is create a I enumerator and do a wait for seconds. And that's going to be, we're going to do bullet timer. There we go. And we're going to say yield return new wait for seconds. And let's put this on a 0.5. That should be pretty good. And then we're also going to say canFire is equal to true, just to reset the loop. Now down here, we're going to say start coroutine, and that's going to be bullet timer with no overloads. And there you have it. And that should work. Now, famous last words, of course, but let's try it out. Okay, so every 0.5 seconds, it's spawning a different one, and I'm holding down the left key right now. If I let go of the left key, it's not going to keep spawning them. So, but there we go. That's how we want it. So now we need the bullets to move, right? Well, now we need the player to be able to fire from all the directions. So we're going to make 4 copies of that. We're going to say right, and that's going to be a plus. This is going to be up, and instead of X position, it's going to be Y position. With the Y, we're going to take that, and we are going to take this, cut that out. We're going to go to here, we're going to paste that in there. We're going to take that X position. Yep, and Y position, this is going to be up, so it needs to be positive. And just to make this simple, we're going to copy this one into there, and this this is going to be down with a minus instead of this white space. And then build that, make sure it works. We can test it out to really make sure it works. So there we go. Fire in all the directions. It's still a little bit slow, so I'm gonna change this to I'm gonna half that time, 0.25. Let's see how that works out. It'll probably feel a lot better for an automatic. Oh yeah, that definitely feels a lot better. So let's end that, and now we need the bullets to be able to move. So we're gonna make another script. We're gonna call this script bullet movement. Go ahead and open that up. Go ahead and reload it all. So we are struck with a problem. We could just say, okay, we are going to make the bullet move in its forward position as soon as it spawned, because the logic behind that would be, hey, well, it's spawned to the left, it should move to the left. The problem is, since we are not rotating it, it doesn't have a set, basically the set forward direction would be up. And there's no way for us to really figure out how how to rotate it quickly and then get the forward and such like that. I personally don't like using rotation. I think it's very finicky. I've never really learned how to use it a lot, but hey, if you want to do rotation separately than this, and maybe you'll find something that I completely looked over that's really simple, but the way that I've always done this is, it's a little complicated, but it does teach you a little bit more. So what we're going to do is we're going to create some booleans. We're going to create a boolean for left, and these are all going to be false, not false. And then we're going to create a boolean for right, up, and down. So now what we're going to do is, on start, we're going to say, okay, since the player is going to be holding down the arrow key, and since the object is going to be created on the same frame that the arrow key is being held down, we can safely assume that the arrow key is still going to be held down when the object is created. So we're going to say that if input dot get button down, not get mouse button, we're doing get key, sorry, get key, just normal get key, and we're going to say left. So if they're holding down the left button, then we're going to set left equal to true. We're going to copy and paste this for all of the other ones. There we go. So now it's, since start only runs at the very beginning of it all, we have the opportunity to basically see what the player has been, holding down, and we can assign that value to the boolean. So we're going to say, okay, if the player held down left and bullet was created, then we know that the player is holding down left, and we can set left equals to true. Also, we can make these else ifs, so that if one reads true, then it won't go through all of this, and it will save a lot of memory space. Well, not a lot, but in the long run, it might, probably. I don't know, just making else stuff. So now in update, we're going to say, okay, if left, then we're going to do this dot game object dot transform dot translate and that's going to be to the left. We're going to make this, let's say, double the speed of the way that the player is moving. So we're going to say negative 0.2f. Double the speed? Yeah, that sounds about right. Negative 0.2f, 0, 0. Also, I can just remove these to make it a little bit simpler. That way, it looks cleaner. And then we're going to say, we're going to use our classic, come on now, there we go, else if, right, and we're going to copy and paste this. And that's going to be the positive direction. Same thing, else if up. Then we're going to take this and put it in the y. Copy this for the sake of simplicity. And we're doing else if down. And that's going to be a negative. So running through this code in our head, it's going to start and it's going to assign the Boolean for whatever it's going to be doing. And then down here, it's going to check whichever Boolean is correct and it's going to move it in that direction. So let's go ahead and test this out. Doesn't seem to be working, so let's figure it out. So we're not getting any errors, which is a good thing. Although I believe I might know what the problem is. The problem is we never put the script on it. So most of the times it's always the simplest explanation. Sometimes you just don't have the right script. So there we go. We have our bullets. They're moving. So bullets do not shoot diagonally. I'm holding both up and right now. They only shoot in one of the two directions. I'm going to leave it like this. I think that adds a little bit more skill to the game. They would have to position themselves around the asteroids instead of just standing in the center and spamming all the different directions. There we go. So we have checked that all its work. So now we have our weapon. We have our ship. So now I think it's time to add some asteroids. So let's put in our 2D object. We're going to call this asteroid. T-E-R, asteroid. And let's make this a knob. Make it 3. Yeah, that seems about right. No, let's make this same as the player. 5 and 5. We're going to make this a nice asteroid-ish color. Yeah, that seems about right. Let's move this over, see it in relation. Pretty good. We're going to drag this down to here, and now we have our prefab. Make sure that's all correct. Okay, so we need to add some colliders, because how is the player going to know? How is the game going to know whether or not an asteroid has collided with the player, a bullet has collided with the asteroid, etc., etc. So we're going to put a 2D circle collider on here, and we're going to decrease the actual collider a bit. So a good rule for game design, at least one I've been told, is always give the player a little bit more leeway than you think they should have. This comes back to the original Donkey Kong game, where the barrels were their hitboxes were smaller than the actual sprites, because apparently in testing there was a lot of concern that the players thought that they had made the jump where they actually hadn't, because it was just a very harsh way of doing so. So if we're decreasing the actual circle collider to its actual limits, and we're going to have the player, and as I said, the bullet can be a little bit bigger because the bullet helps the player, so the bullet can have a little bit more leeway. And it can hit up here, it can hit up here, stuff like that. So that's all up to you. If you want to make a harder game to make the circle hitboxes bigger, bullet hitboxes smaller, etc. But for me, I'm going to make a very a nice game for the player. And now for the player, I'm going to make this hitbox a little bit smaller. I'm going to let the asteroid come into the player just a little bit. To give them just a little bit of the taste. Just to let them know that they're all safe. And we're going to stop that. So now we have our colliders. We have our bullet collider, player collider, asteroid collider. So next we need a rigid body for our player and for our bullet. Without the rigid body, we won't be able to use a bit of code that's going to come next. So we're going to go to 2D, rigid body. The rigid body is really interesting. This is what I showed you in the last video, where if you just play it, player is just going to drop. Rigid body includes gravity, but since we've already created movement, we don't want gravity anymore. So we're going to go and we're going to turn off, yes, we're on the player, we're going to turn off simulated. Oh no, we are not going to turn off simulated. I was incorrect. We're going to set gravity scale to 0. That's what we're going to do. So that way, it still has the rigid body. As you can see, it's kind of moving around like that. But it is not falling. We're going to go down to constraints, and we're going to freeze the rotation so that it can't really rotate around anymore. There we go. Next thing we're going to do is we're going to make the collider for the player and the bullet. We're going to make them trigger. And I can actually get rid of that, since basically what making the collider trigger does is it means that it's not a physical collider anymore. You can't actually hit anything with this. It will just, it'll make a trigger. It's like a switch. If something happens inside of that collider, then a switch will flip, and we'll be able to access that in the code. For the bullet, we're also going to make that trigger, and we are also going to add a rigid body to this. Set that gravity to 0. And then out here, we're going to click apply so that the prefab updates with that as well. So you might be wondering, why don't we make the asteroid trigger? Well, the way it works is there needs to be at least one collider for all the other triggers to work. So if you didn't have that one collider, then all the triggers would mess each other up. So this way, having the asteroid as a non-collider, as a non-trigger, will be fine. Now, rigid body is the only thing that actually collides with other things. So if we put these two asteroids on top of each other, they're not going to expel away or do anything like that. However, if we put a rigid body on it, let's take this out, then it would fall down. So rigid body collides with other colliders like so. It does not collide with triggers. But yeah, that's how it works. Just do it like this. We can actually see it fall. Yep. So that's why we don't want to use rigid bodies in this game. We don't want to have the colliders really mess with anything else. Okay, so now that that has been done, we want the asteroid to follow the player, right? At least when it's spawned. So over here, we're going to make another script. We're going to call this, you guessed it, asteroid movement. Oh, no spaces. Okay, so now asteroid movement is created. We're going to open that up. Go ahead and reload all. So what we're going to be doing is this dot GameObject dot transform dot position equals new vector 3. Not going to be new vector 3. It's going to be vector 3 dot move towards. It's a very special function. It moves towards something, as you can probably guess. And if we hover over it, we can see what we want. So the vector 3, that the first one is going to be the current, third one's going to be the target, and the second one's going to be target, and the third one is going to be the max distance delta, or basically the speed. So we're going to, for current one, obviously it's going to be this dot game object dot transform dot position. So do we have that down? Now we need our target position. That's going to be player. Well, we need to actually make something first. So we're going to do public game object player. We're going to do this dot player dot game object dot transform dot position. And we're probably going to want this to move. There we go. We're going to want this to move half the speed of the player to give them a little bit of a fighting chance. So if the player moved at 0.1, we're going to make them move at 0.05f. Let's go ahead and build that. And actually, what am I saying? This, it's not this. That would refer to this. Let's go ahead and build that. Come over to here. We're going to attach that to our asteroid now. And we're going to say the player is, player, this guy gets deleted. Player is here. Now, we might run into a problem here. Let me show you what's going to happen. We have to probably put an asteroid in there first. So, the game starts, asteroid moves towards the player, but the asteroid does not follow the player. What's going on here is the asteroid is following, since the player game object we put in here was the actual prefab, it's going to the prefab's position, which is at 0, 0. In here, since the asteroid's in the game, if we put the actual player object in it, it would follow the player around. And that seems to work just fine. However, we want the asteroids to be able to be created and then follow the player. We don't want them to have to follow 0, 0 because it's going to break the game. So let's go on back and we're going to try something new. So we declare a player up here. But what we're going to do is we're going to take the at the very beginning, once the asteroid is created, it's going to find the player, and then it's going to find the player, not the prefab, and then it's going to move towards that player's position. So let's do something first. We're going to put a tag. Tags are great. We're going to make this player tag. So tags are a very certain thing in Unity that you can use to tag things. Many things can have the same tag, but things cannot have more than one tag. After you create a tag, you need to assign it, so don't forget to do that. So the player now has the player tag on it. I could have also used player tag here, but I wanted to show you how to use the tag. These 7 come already loaded in. You can use these if you would like, or you can make new tags. So now we have that. We're going to go to here, and we're going to say, okay, we want the player to equal. First off, we can remove this, because we're not going to be assigning it in here anymore. Game object, capital game object, and then we're going to do find object with tag, or we're just going to do find with tag. Find with tag, and it's going to take a string. So we're going to put in the tag exactly how we wrote it, player, with a W. And then when we build it, what's going to happen is as soon as the asteroid enters the scene, it's going to find the tag, it's going to find the game object with the tag player, it's going to assign that to the player, and then it's going to be, it's going to follow that. So under asteroids, in here, we can't see, it's not being declared. We can't see if it's declared or not. However, we know it works because it is following us. Now, even if we You might be thinking, well, it's because we assigned it last time. Even if we brought in a new asteroid, it would do the same things. There we go. Now we have an asteroid that follows us, but unfortunately, none of the colliders are working right now. So let us change that. Actually, now that I think about it, we're gonna change that next episode. We've had a lot this episode, and in my next video, I will show you how to make the colliders work, how to destroy the asteroids, and how to have the asteroids destroy the player.